All right, thanks everyone for coming out. We're going to be talking about service workers and the Angular service worker module in specific, and kind of talk about how we can get some offline and performance benefits. So, like we do with a lot of technology, it's good to know why we want to adopt something. And I think this infographic is really telling. On the left side, you can see that in this poll, the top 1,000 mobile apps versus web apps, the mobile apps get about 3 times more traffic. But when we look at the time spent on those applications, the actual mobile apps or the native apps get much more than the mobile than their website companion. So a lot of things probably go into that, but service workers help bridge that gap between native app and web desktop experience. And so what we're going to look at tonight, I think, is going to help bridge that gap and give a better user experience compared to a native web application. A lot of things have changed in the past 6 months. Service workers are now generally supported across all Evergreen major browsers. So this includes Edge, Firefox, Chrome, Safari, as well as iOS Safari and Chrome for Android, as well as a couple others. So it's generally safe to invest some time to realize the benefits of the service worker. So there's definitely other ways you can implement a service worker. Workbox is a really popular library that'll provide a wrapper for you. If you're using some other technologies, that's probably a good way to go. However, Angular has its own module and set of services that they provide for you to interact with the service worker. And it's going to do a lot of the same things as other libraries. But it makes it really easy to use. And so from a high level, it's going to group all of your bundled files, basically everything in the dist folder with a version. It's going to take all of those hashes and basically create a version of your application. So as those files changes, you'll basically, in the service workers context, create a new version and it'll know to update. So again, this includes all your HTML, CSS, JS, JavaScript. It works with the lazy loaded modules, so you don't really have to worry about much. And as we'll see in a second, there's a ng-sw config file that will set things up in, and then this is going to publish a ng-sw JSON file in your dist folder, and that will basically handle the communication between the service worker on the client and your configuration for the application. I think understanding how a service worker updates is probably one of the most important things before you start interacting with this, because it may be a little different from what you're thinking as far as when I push up a change to my server and I access the web app, we're not going to see it right away. And that's for a couple reasons. But we will, every time we view or refresh the application, Angular is going to request that ng-sw JSON file with a cache busting parameter. And that's going to make sure that it always gets, that's going to be the one thing. If you have your whole entire application cached, that thing's always going to be requested. So that the application of your client can know, do I have the most latest state? Or do I need to perform an update? Or do I need to prefetch something? Has something changed in those bundled files? So that request is always going to be made. And depending on the policy for your assets, the service worker will then either wait for the next request if it's a lazy prefetch, or if you've told it to go ahead and download those things, as soon as it knows that a new version is available, you'll see those requests being made in your network tab. And this is just a kind of a good infographic on the flow. So if we look at these solid lines first, this is basically I have the service worker installed and things are cached. So if we have a performance policy, we'll make a request to the service worker, and the service worker is going to sit kind of like a man in the middle between our application and the network. And so everything's going to go through the service worker. And if we have this kind of performance policy where I just want the data as fast as possible, it's going to check the config file for the hash, realize that it has it in the cache, and return that straight back to the client. And then another scenario is, say, maybe I have a network first or a lazy approach for an asset. So it's going to check the service worker and say, okay, I'm supposed to always fetch the latest on this. So I'm going to go out to the network. Once I get that back, I'm going to put it in the cache and then send it back to the client. So there's a couple different couple different options for your assets, but the service worker is always going to sit in the middle between all these assets. So this is what the Angular team provides for us to interact with the service worker, and it makes it really easy. They provide two services. One is SW update, and obviously that's going to be for all of your service worker interactions. So anytime you have an update to the service worker, this service is going to handle that. And there's also a SW push. So if you want to interact with push notifications, well, they also provide that service as well. And we'll configure everything in this ngsw config file and adding it. Of course, if you use the CLI, you can do ng add PWA, and this will handle a lot of it for you. But this line here in your root module will be where you will configure and initiate or instantiate the service worker module. So you'll just pass it the file, and also we will enable it only for production as well. So a lot of the integrity, again, relies on those hashes to know when the file has changed. So we'll want to only typically run this with a production build and not with the typical ng-serve. So in this config file, which we'll see in a bit, there's really two main groups that we're going to configure our assets in. One is labeled assets groups, and these again are going to be your core files that you're working with. So your HTML, JS, and CSS, Fabricon, etc. Basically anything that gets a hash and dumped into the dist folder. And based on all those hashes and those files, that will determine the application version and when it updates. And there's two modes that are important to know about: prefetch and lazy. Prefetch is just like it sounds. If you're telling that this asset needs to be in the service worker, it will go ahead and fetch that before it's ever been hit. Whereas lazy waits for you to request it before it puts it in the cache. And you can specify that interaction for both the install mode and the update mode. So whenever you make a change, you can say, I want this to, that's great, we've got a change, but you know what, just wait till the next request. So I'm going to do a lazy update mode. The second group that we're going to configure is the data groups. And for these policies, these are going to be like your API requests. So things that exist outside of your dist folder. This will be your backend server, basically things that don't have a hash or a version to them. And they're generally going to be cached according to the HTTP caching policies that are applied from that server. But they give us similar configuration like we saw before. So we can do a performance where we specify a max age and say that once this is requested, I want to use this version for the next 7 days or 7 hours or year, however long you define it. And on the inverse of that, we can say this is crucial to our application functioning, that we have the latest data, so I want you to always hit the network. But in this case, we can define a timeout property and say, I always want you to hit the network, but if this thing takes longer than 2 seconds, fall back to the cache. And it makes it really easy to set these up. Like I said earlier, in those data groups, this is going to be your unhashed content where you're going to set up those policies. And it still caches, but again, it honors the HTTP caching headers. And when it expires, it'll just follow the normal flow of serving it from the cache and refresh in the background. They put a lot of work and thought into maintaining the integrity of your application, because it's pretty easy to envision how your app can get out of sync when you have these different versions. And maybe I change one file, like my index or something, .html or my home component, and now my main bundle's different, something like that. So again, like I said, all those files are hashed. Those hashes make up the version in the service worker. And every time your application loads, it always fetches that config file with the cache busting URL. And if that fails, the service worker will invalidate that entire version of the app. So the next load, you'll just get a fresh download from the network. It'll bypass it. And they also have some safe modes. So you can, if things get really hairy, it can enter itself into a safe mode. You can also programmatically do this by changing the name of I believe it's the config file. You can either remove it or change the name. It'll basically just kind of self-destruct and get out of its own way. I think that talked into my next slide here. So yeah, remove or rename that config file, and the service worker will deregister itself. Or if any time that file that it cache bus returns a 404, it'll just remove the cache and deregister itself. And one of the things they also offer is a new route for your application. So if you go to your application and go to ngsw/state, you can get some kind of low-level debug information of how is the service worker functioning at this moment. So you can get version information, the state of it, the last hash, those sorts of things. All right, so we're gonna look at a quick demo and kind of see how some of this stuff is set up. First, going to show you so this is the app we're going to be looking at. This is this is public. You guys can look at it later. Very simple. Really two views here. This one is just static, so we're just going to look at like what are the default files that our application is going to download, and then this one has some dynamic data that we're going to be looking at, both a API payload, and then these images are going to be our kind of dynamic, let's say, important things that we don't want to cache. So we'll look at how to set these all up and what's going on. So I've got this demo running right here. I just ran a ng build prod basically to hash all the files, and then I'm serving it statically from the file system. So if we access our little application here, everyone see that okay? Good, cool. So we can see that making a lot of requests here. We can see the size of the assets. We've got our hashed content over here on the left, and this is kind of a clean. This will be the first load, or the first view of this application. And so our service worker has installed. So when we come back the second time, that's when the service worker is going to be enabled. And we can see that these files are now being called from the service worker. We're only downloading about 3.1K here. So the if we go back and look at our config file, we can see we're specifying the index, and we see our asset groups right here. So each group requires a unique name, and we have the install mode of prefetch. So it's going to, whether it's requested or not, these resources are going to be prefetched so that they're ready. We've got a second group down here called assets. So anything that's in the assets folder. Right now we have this set to lazy, so we're only going to download these as needed, just kind of like a normal flow. However, updates are going to be prefetched. So when we say that there's an update, when our service worker realizes that, it's going to go ahead and download those. So again, we hit it the first time, the service worker installed. Second time we come back to the visit, the service worker takes over and proxies those requests and says, hey, I already cached these the first time, and it's just going to serve it straight from the cache. So let's come over here, and we are going to add some URLs. I'm going to close this sidebar so we can see. We're going to add some of the basic Google fonts to our assets here, and the CLI provides a good way to kind of test these changes out really quickly. Instead of redoing a prod build every time, you can just run this ngsw config module and pass it the directory to where the dist folder is outputted to and the config file. That'll basically generate a new service worker config. So we're just updating that in our local static server. And I messed up the JSON. Probably. Was it not like? I'm gonna set this one. Yes, there we go. Don't need that. All right. So pretty quick to update package.json. So this is like, hey, we've published a new version of our application. I'm going to close this out. I'm going to come back later to my app, and we can see that. Look down here in a second. Here's our cache busting request for that config, and we can see that it went ahead and prefetched all these apps here, and reload. We can see that now everything is being served from the service worker, from our default route. It's a little bigger here. So all of our assets are now cached. We're not making a network. The only network request we're making every time is this cache busting request. So next, we're going to look at our little launches page here. If we hit this, we can see that we have this launches API request. And this is just all our JSON for all these SpaceX launches. And so what we're going to do to handle that is we're going to add a data group. And again, we're going to give it a unique name. This is kind of our ID. We're going to pass the URLs that we want to cache. So anything at this path. We're going to choose a performance strategy. So it's always going to check the cache first. And we're just going to store one of these requests, and we're going to store it for 7 days. And they actually provide a pretty unique way. You can just do like 7 minutes, 7 hours. You can do 30 minutes. They provide kind of like a little DSL for deciding how long you want to cache something. So we're gonna cache this API request for 7 days because in our app we know this isn't going to change. And we're also going to provide a fallback image. So if we go offline and these badges we're kind of treating as like really critical data. We always want to request that first. But in some case, if that's not, we're going to go ahead and say prefetch. In our assets folder, we're just going to download ahead of time so that it's available and ready for our application. I'm going to update our service worker config file. We're going to simulate that we come back at a later date. We will get our cache busting request on there. And so our service worker is updated. Again, we'll need to come back the second time to get the update, the actual implementation of that update. And let's see here. So now, since we cached all those assets, I have this little fallback image in here. So you can see as we toggle back between online and offline, we can see that we have a fallback image in place. So that image exists in our assets directory right here. So we went ahead and prefetched that by changing this from lazy to prefetch. And we can also look at our launches API. And if we hit this again, we can see that now it's being served from the network, from the service worker, I'm sorry. So at this point, we've configured all of the dist files. We figured our API. And the only thing we're still manually requesting time are these badges. So those are the only network requests that we're making in this scenario. So that's kind of the demo app. I'd like to show you guys how the service is set up. So we go down here to the app status service. So we can see we're injecting the service worker update service from that module. So it's coming from the service worker. And it provides a couple methods. One of them is available. So anytime that a new version is available, we can execute this method here that we're using as a callback. And so if we have an event.available, I've just set up a little behavior subject that we can expose to the rest of the application, and we're just nexting the new hash to the application. So this is how you can kind of programmatically tell your users, hey, you're using an outdated version of the application. Would you like to update? And we can see that you may have saw that on a couple refreshes, but if I just change one thing here, publish a new config, and then we'll revisit, we'll see we get the request for the new JSON, and now we have a new refresh button, update available at this hash. So we can programmatically prompt the user to update their application, get the new service worker, get the new code. Another thing is they provide a method for, sorry about that, notifying the app when a new version is loaded automatically, and activating a new update. So this is how we're reloading the app. We're calling activate update, which just posts a message to the service worker's inner scoped, and then we're just doing a simple document.reload. I'm also in this demo just exposed when an update is available. So this is when we're calling next on that behavior subject. So we can key off of that. And then the fallback image is keyed off of this online observable. So we're looking at a couple things, the global online method, as well as the window.offline, and setting that here. So that way we can toggle this and have this respond dynamically as the app switches online and offline. If you want to show some sort of fallback or some sort of indication that, hey, this app is not going to function correctly, we'll resync when you join online in the future. And I think, again, here's that loading button. I've just exposed this as a public member. So when it's available, we're going to show that refresh button. And when you click on it, we're just going to call reload for this example. And for the launches page, with all those launches there, we have a online status that's just subscribing to our app status service. And we just make a simple request to get the JSON payload. And then our image is keyed off of that online observable. And so if we're online, we can show the dynamic mission patch. Otherwise, we fall back to the default asset. And that's pretty much it. We can also look in our dist folder. This is what gets published. So when that this ng, split screen this here. On the left is where we do our configuration, and on the right is what gets published every time and downloaded by the service worker. And this is used to indicate when a new version is available. So it's taking all these hashes into account. It's indicating all the asset URLs to prefetch. It's got our patterns for our fonts. And here's our API requests that we are utilizing. And then we have this big hash table of how it's keeping track of when things change and when it needs to update. So back here. All right. That's a quick demo on the service worker module, how you can use it, how easy it is to configure. It's pretty straightforward to at least get your app shell cached by the service worker, things that aren't changing that often. Maybe your sidebar, nav bar, just the defaults. You can at least not make your clients pay for that download every time. And when there are downloads, it's pretty straightforward to manage getting the latest data as well. And lastly, a couple links on here. There's some interesting things on how much data you can store in a service worker. So every client's a little bit different. So if you have a lot of data that's necessary to be there, you want to be cognizant of that and what devices that your clients are using. This is a pretty interesting link. This will, whatever you look at this in, this will show you what features are available on your client. So it's kind of, you can run this in Chrome and Firefox, Safari, and see what's being supported. Lighthouse is a really good tool for testing and benchmarking your app. So it tests a lot of things. One of those things is the service worker in specifically. And, you know, that's more kind of going towards a full-on progressive web app, but still a service worker on its own implementation provides a lot of benefit. You're looking to test a service worker. Interestingly enough, Pinterest has a what looks, I haven't tested this myself, but they look like they have figured out a lot of how to test service workers. So that's a good thing to know. And then I've got the link to the demo on here if you guys want to take a look. Yeah, question.
Do you think you can run one of those feature detection on an ID browser?
I don't have ID. No, it's a Mac. Sorry. Yeah, so if we come back.
So will you know, which book the edge?
He's not looking good, but
surprise, surprise.
Yeah. But there's hope for Edge.
Where can we find this?
So we will post. I will post these slides in somewhere in fashion. We'll post it on the Meetup page, or sure we'll put it on our Twitter or something like that. And yeah, a lot of these other ones down here were just resources that I used to put the presentation together.
So it looked like that global online was either true or false. What do you do about like Starbucks, like internet, internet? So you're like quasi, you're going like in and out, or like the connection speed is really slow.
Well, that online piece was, let's see. Online piece was a collection of these properties. So I guess it would depend on how these are interacting with, you know, if your network is actually dropping in Starbucks in and out, then I would imagine that these would switch on and off on time. Slow connection, I don't know if these would fire or not. I don't know if there's a way you could programmatically watch that from inside the application, but.
Can you simulate that in Chrome or you create the network?
Yeah, so yeah, there's in the network tab, there's an offline button here. So we're under network, on the top there's offline, and that'll
slow down.
Oh yeah, slow down the network. Yeah. I think the slowest.
Oh yeah. It's America. It's slow.
Yeah, I was just wondering, once you slow it down, you know, how does it pick up the icon?
Did you say you pull the cache version if it took longer than a couple seconds?
Can you do a shift, play out the cache and then fire it?
Yeah, so let's we can unregister the service worker.
I imagine too, if you're having slow intermittent internet, you can just put a set timer, if offline for 5 seconds, then or is that an issue or not?
Still fast enough, I guess.
Let's go to Starbucks.
Yeah, everyone pack up. Yeah, I mean, there's not a lot. It's pretty small. Yes, you'd have to.
A way in the framework to say, hey, this takes longer than 10 seconds. Browser cache.
Yes.
Okay, so you can actually. Okay.
Yeah, so we can say. So these two kind of go hand in hand. So when you have a performance strategy, you would set the max age property. So we're saying pull this from the cache from when it's instantiated to the net for the next 7 days. After that, default it. So if we do lazy, this becomes timeout. And we say, try this for 2.5 seconds. If that takes longer than 2.5 seconds, then it's going to fall back to the cache. So you would just inverse those properties if you wanted to apply a policy for those assets.
You mean fall back to the default, the little rocket?
You could configure.
Image there.
You could configure it that way. Although if I would imagine once this lands the first time, it's going to put it in the cache as like a backup, whatever the actual the response is. And then in this case, it's going to say, go to the network. It's going to fail. It's going to just hold that stale response. Yeah, questions? Yeah.
When it comes to choosing what goes in an asset group, what do you typically decide that on?
Like which one does it go? Data group versus asset group?
Well, just asset groups for now. You have multiple groups. What do you use to determine as to what makes a group?
Okay.
Like, there's the home page that's getting loaded first, and then maybe there's a product page. Maybe then there's an asset group for every asset on the product page.
Yeah, you could break it down like that. I think features is probably one good way to look at it. If you have a bunch of lazy loaded assets, like maybe we don't want to download those things. Maybe it's like almost a whole other app to itself. So let's silo those. Let's only download those as necessary. Or maybe they're pertinent. You just don't want to like make the user wait. So then you can say, okay, let's for these set of assets, let's create a policy that prefetches them. Right? We don't need them, and that's what we did with the Rocket asset. Essentially, is that if it was lazy and we went offline, well, I've never downloaded that asset, so it would fail. It wouldn't show up. So in order for it to be ready for the offline mode, that's why I changed it to prefetch. So I went ahead and downloaded it, so it was ready.
Did you catch that?
That's good questions. Any more questions? Yeah.
I guess I don't know if it's head, but then I guess going back the other way, if you have a whole bunch of like users interacting, you have really like store the changes they're making and then sync them back to the server.
Yeah, I mean, I think you could, whether that's a API request, we can store these things. We can refresh programmatically, like I showed, by making this publicly available. We can present them with hey, things are about to change. Do you want to change them? So we could maybe save that to the database. Maybe we save it to local storage, something like that. So I think any sort of storage mechanism that persists, you could probably just dump it in there and then just have your app read from it every load. Like, is there anything in there? Cool. Any more questions? Awesome. I appreciate you guys coming out. Yeah, thank you. We'll put all this stuff online.